Hello, everyone. Sorry I have to be gone today. I'm at a teacher conference in Dallas, Texas, so hopefully I'll bring back some warm weather for us. As far as yesterday's homework, go ahead and hold on to that. However, I think we should have two presenters, so before even starting the lesson, I would ask to make sure that the two presenters have presented their problem on the whiteboard. So if that hasn't occurred yet, go ahead and pause the video now so that they can share that. Otherwise, if we've already done that, that's awesome. And we can start with today's lesson. So today we're looking at section 5 in chapter 4, so 4.5. We're looking at graphing using slope-intercept form. To start though, what I would like to do is do two warm-up questions. One is on finding the slope between 2 points, and then the second one is an old tool that we have for graphing. So the tools that we have for graphing so far is we have graphing by making a table and plotting random points. And the other one we have is making a very small table to find the x and y intercepts and then connecting the x and y intercept together to make a line. So those are our two. Today we're going to get our third tool for graphing lines, and that's using slope-intercept form. Before we start that though, what I would like is if we tried these two warm-up questions. The first one is to find the slope of the line that passes through the point -5, 6 and 0, 8. And the second question is to find the x and y intercept of the equation 8x minus 5y equals 80. So pause the video now. Let's give it 3 minutes for everyone to try this. You can try this at the bottom of your homework from the prior day. And after 3 minutes, I will go over it. So please pause the video now and we will come back to it. Okay, welcome back. Let's start by going over the first one. So the first one is finding the slope between those 2 points. So slope, we have to recall, is equal to my rise divided by my run. My rise is my change in my y's. So how far apart are my y's? y2 minus y1. And my run is how far apart are my x's, which is x2 minus x1. My second point's y-coordinate is 8. My first point's y-coordinate is 6, so it's 8 minus 6. My second point's x-coordinate is 0. My first point's x-coordinate is -5, so we have this. 8 minus 6 is 1. And then on bottom, 0 minus -5 is 0 plus 5, and that is 5. So the slope of the line that connects those 2 points in question 1 would be 1/5. I'd have to go up 1 over 5 every time to land on another point on the line. The second question, question 2, is to find the x and y intercepts. So question 2 here is going to be, well, what I really want to do is I want to make a little table, x, y intercepts. To find the x-intercept, what I'm going to do is I'm going to set the y-coordinate of that point equal to 0. And if I set the y-coordinate equal to 0, my equation then becomes 8x equals 80. And if I divide by 8, I find that my x-intercept will be 10. So I know the point 10, 0 is going to be on that line. Now I'm going to go and I'm going to find the y-intercept. To find the y-intercept, I set x equal to 0. If I put 0 in for x in this equation, it's going to become -5y equals 80. And then I divide both sides by -5, divide by -5. I get y is equal to -16. So I know my other point is going to be 0, -16. I know those 2 points. All I need is 2 points to graph a line. I connect those 2 points and I would have the line graphed. So that's one of our tools. Today we get our third tool. So please, right now, make sure everybody has their notes out. So get your notes out, open it up to section 4.5. It's 4.5 day 1. So do that now. If we need to, pause the video until everyone has it out. Otherwise, I'm going to assume we're all ready to go. So moving on to the first part from your notes. The first question is, let's use what we already know to discover what we're going to be using as our new tool. So the first example is just to fill in the table and then graph and state what you notice. So we already know how to do this. We've graphed before by making tables. We chose 0, 1, 2, and 3 for x, and then we found y by plugging in those values for x. So this first one, if I plug 0 in for x, it becomes 5 plus 2 times 0. And that is just going to be y equals 5 plus 0, so y is going to be equal to 5. If I put 1 in for x, my equation then is y is equal to 5 plus 2 times 1. 2 times 1 is 2, so it's 5 plus 2, and that's what gives me 7. On the next one, x is equal to 2 in my table, so I'm going to put 2 in for x in my equation and find what y is. I get 5 plus 2 times 2. 2 times 2 is 4. 4 plus 5 is 9, so I get 9. The last one I'm going to do is put 3 in for x in my equation. 5 plus 2 times 3. 2 times 3 is 6, plus 5 is 11. There are my points, and now I'm going to graph them. First one is 0, 5, so up there. My next one is 1, 7, which would be right there. Then I have 2, 9, should be right there. And my last one is 3, 11, it should be right up here. I have them, and the next thing I can do is do my best to sketch in a line. It'll look something like so. And I've graphed that line. What do you notice? Well, let's look at this. Let's go back to my table. I'm going to erase all this work we did right here. And what do you notice? Well, let's look at this. Where does y start? When x is equal to 0, where does y start? It starts at 5. And how does y change? Well, we are constantly adding 2 every time. Adding 2. Adding 2. And how does that translate from my equation? Well, let's look. This equation says y is 5 to start. And when I mean start, it means when x is 0. When x is 0, that's when we can say where y is starting. It's the y-intercept. And what are we doing? We're adding 2 for every x. And where do I see that over here in my line? I see it right here. That is the y-intercept right there. And that comes from the very first point in our table. If we start with x equals 0, there's y is 5, and what are we doing? We're going up 2 over 1, up 2 over 1. So what do I see? I see my y-intercept is equal to 5. And what else do I see? I see the slope of this line is up 2 over 1. Up 2. That's how much my y increases every time my x increases by 1. That gives me a slope equal to 2. So what am I seeing? I'm seeing that this point right here, the number all by itself is my y-intercept, and this right here is telling me my slope. It's telling me how my equation, my line, is changing. Let's try it with a different one. So moving on, the next one is 3 plus x. I'm going to fill in my table here, and then we're going to graph it and state what we notice. So the first thing I do, I'll just show it for the first one. I'm going to put 0 in for x, so I get y is equal to 3 plus 0. 3 plus 0 is 3, so I see where does y start? Y starts at 3. Next one I'm going to do is put in 1. So I get y equals 3 plus 1. I'm putting 1 in for x into the equation. That gives me 4. So my next point is 1 comma, oh, that should be 1 comma 4. I might have changed this before going in. So this right here, let's cross it out. This should be a 4. I'm guessing the other ones are incorrect. If I put 2 in here, I should get y equals 5. So that shouldn't be an 11. That should be a 5. And then the last one, if I put 3 in for x, that should not be a 15. That should be a 6. So my table should actually look like that. 0, 3 is my first point. So I'm going to go over here and plot my points. 0, 3, and then 1, 4. I changed it because it didn't fit on my graph. 2, 5, and then 3, 6. And then I'm going to sketch my line in and then state, what do we notice? Is there a faster way we can do this besides making all the points of that table? Yeah. Let's look back here. Where does y actually start? Y starts at 3. That's my y-intercept. This says y is 3, and what are we doing? We're adding 1 for every x. And that's what's going on here. Starts at 3, then I add 1. Then I add 1. I add 1 for every x I move over. So I see my y-intercept right there comes from this guy. My y-intercept is equal to 3. It's the number all by itself in the equation. And then what are we doing? We're adding 1 for every x. Well, that's my slope. Up 1 over 1. Up 1 over 1. my slope of the line is equal to 1. Those are the two key features we can pick. Where does y start? As long as I'm picking my first x value as 0, then that first y is going to be 3, or is going to not be 3, it's going to be my y-intercept. In this case, that is 3. Okay? You try on your own. So on the whiteboards, if you would now, please pull them out and try this yo-yo. So the question is to fill in the table, graph, and then state what you notice. It's y equals 8 minus 3x. So try it now. And then pause the video when everyone's had a chance to try it. Okay, welcome back. Let's start. When I fill in my table, it should end up looking something like this. And what do I notice? Where does y start? Y starts, hey, at 8. That's my y-intercept. That's this point right here. So when I graph, it looks like 8. And then my next one's 1 comma 5, and then 2 comma 2, and then 3 comma negative 1. Draw in my line, something like so. So here's the key features. First key feature is this guy. It's my y-intercept. And that comes from this right here. Where does y start? Y, if I read this off, if I translate this equation to English, it says y is 8 and goes down by 3. And I see that in the table for every x. And that down by 3 is really the slope. Down 3, that's my rise. My run is 1. Down 3, right 1. So that 8 is my y-intercept. My y-intercept is equal to 8, and my slope is equal to negative 3. And that's the key feature that we're noticing. When I have an equation solved for y, I can read off the y-intercept and the slope. And that is called slope-intercept form. So this is in your notes already. It says finding the slope and y-intercept of a line. If you look in your book, you're going to see this. A linear equation of the form y equals mx plus b. They use m to stand for slope. So m stands for slope. And b stands for y-intercept. If it's written in y equals mx plus b, they call that slope-intercept form, where m is the slope and b is the y-intercept of the equation's graph. So the example of the line they give is y equals 1/3 x plus 1. I want to give a big kind of warning here. When we're first learning it, I think it's easier if we write the y-intercept first. So I think it's easier when first learning it to write it as y equals b plus mx. So I'm going to do that a lot here in the beginning especially, and in the next chapter, because I think it translates nicer between the table and the graph. However, the rest of the world writes it as y equals mx plus b. If you go to China, they'll write it like that. If you go to India, England, Brazil, they will write it as y equals mx plus b. And the reason they do that is because they write their highest powered variable first. But I think when learning it, it's easier to write it as the following. So this first one, instead of writing y equals 1/3 x plus 1, I would write it as 1 plus 1/3 x. And there's no difference between that. That's the commutative property of addition, saying 2 plus 3 is equal to 3 plus 2. It means the exact same thing. So when we are writing this, I'm going to write the number all by itself first. I'm going to write the y-intercept first. So I'm actually writing intercept slope form because I write intercept first because I think it's easier to say where do we start? We start with the y-intercept, and how does our line change? It changes by the slope. So that's how I'm going to write it, but no, if you look in the book, they're going to write the slope first, okay? And it shouldn't be an issue though. So what could I say about this equation? Y equals negative 3/2 x plus 6. That might be how some student writes it in London. When we're first practicing this, I'm actually going to write it as y equals 6. And then that's a negative, so I'm going to say minus 3/2 x, like so. Just rewriting the order of these. When I do that, I think it's easier then because I note, hey, that number right there, that is the y-intercept. That is where y starts. So my y-intercept, which we call b, we would say b is equal to 6. The slope is this right here. It's negative 3/2. So I'd say slope in this case, which we use the letter m in our equation, is equal to -3/2. And I can graph it now. Just by knowing that. I don't need to make a table. I've kind of seen how this works, and I can be quicker than that. So we're going to graph this down below. I want to graph 6 minus 3/2 x. Where do I start? I start with my y-intercept, which is right here at 6. That's where my story starts. How is my line changing? Well, my slope is down 3, right 2. So from here I go down 1, 2, 3, right 2, put down a point. I could do it again if I want to get another point. I go down 1, 2, 3, right 1, 2, have a couple points. And now I can sketch in my line. My line looks like that. All I needed was my y-intercept and my slope. Okay? You try this guy. So on your whiteboards, on the back side, use the graph. I want you to first tell me what the slope and the y-intercept are. So I would rewrite it so that your y-intercept is first. So the number all by itself is first. Once you have the slope and the y-intercept, then graph it. So pause the video now. Let's take maybe 2 minutes for everyone to try this. Come back after it's been 2 minutes and everyone's had a chance to try and check with their neighbor. Okay, so pause the video now, come back after 2 minutes. Okay, welcome back. Like I said, I like to write the y-intercept first. So I'm going to rewrite this as y is equal to, that's a -3. Don't forget the subtract up front means negative, so this is -3, and it's a -1/2 x. Okay? When it writes it, when it writes it as a subtract out here, that means that's a negative slope. Some people wonder, is it -1/2? Is it 1/2? It doesn't really matter, but it's better to think about it as the top number being negative. So I think of it as a negative rise when I'm thinking about my slope. Okay, so now I can pick off, hey, this is my y-intercept. It's where my story starts. If I was translating this, I would say y is means equals, so y is -3. That is where it starts when I'm graphing. So to graph it, I need some graph paper. I start this at -3. So I put my first point down here at -3. And then what's the slope? Well, that's this part right here. My slope is, like I said, -1/2 because it's a subtract. It doesn't matter which one I think of as negative, but it's better to think of the top number as negative because that's what most people think of it as. So to get another point, we need to go down 1 because that's our rise. Right there is our rise of -1. Our run is +2, so that's to the right. So we need to go down 1, right 2. I can do it one more time, down 1, right 2. Have a couple points. Sketch in my line. Not too bad. All I need is a y-intercept and a slope, and I can graph a line. Cool. Last questions we're looking at is what happens if y is not already solved for? Well, that's why last chapter we practiced solving for y time and again so I can easily read off the slope and the y-intercept. So my goal here is to find the slope and y-intercept of the following function and graph it. Well, my first step is to solve for y so I can read off the slope and y-intercept. So I think to myself, what am I trying to solve for? I'm trying to solve for y. So here is a y term. This is a not y term and a not y term. So what are my steps for solving? Simplify, same side, solve. I can't simplify here. There's no distribution. There's no like terms already on the same side. So my next step is to get same side. So I need to get my not y terms, these squiggle terms, on the same side. And how am I going to do that? Well, I need to undo subtract 4x. So I'm going to add 4x to each side. So add 4x. This is how I show my work. Below, add 4x. Now, just y terms over here, 2y equals 14 plus 4x. Now my last part is to solve for y. So I've got same side, now I need to solve. Divide by 2. Now divide everything on the left by 2, divide everything on the right by 2. Divide by 2, divide by 2. So I get y, 1y, because that's what 2 divided by 2 is, it's 1. 14 divided by 2 is 7. And 4x divided by 2 is positive 2x's. So there is my equation. I can read off what the y-intercept and the slope is. My y-intercept is 7. That's where my story starts. It says y is 7. So I put that point down. That's my y-intercept. How is my line changing? Well, that's my slope. I'm going up 2 for every x, going up 2 for every x, because if I wrote that slope right there, 2 as a fraction, it'd be 2 over 1. My rise would be 2, my run would be 1. So to get another point, I go up 2, right 1. I could get another one, go up 2, right 1. And I have enough points. I'm going to sketch in my line. Looks something like so. And there's my line. All I needed was the y-intercept and the slope. So I found the y-intercept. Y-intercept right there is 7, and my slope is 2. So slope is equal to 2 in this case. I have the y-intercept and the slope. I can easily graph it. My first step is put down the y-intercept and then use the slope to say how my line is changing. You try this last yo-yo. So on your whiteboards, flip them to the back side. First step is to solve for y. Once you've solved for y, then go ahead and graph the line. Okay, so find the line, state what the slope and y-intercept are, and then graph it. So pause the video now. Give everyone about 2 minutes to try it. So pause video now. Give 2 minutes to try. Get an answer. Check with your neighbor. Make sure you're doing it right. And then we'll compare. Okay, let's go over it. First thing I need to do is I need to solve for y so I can read off the slope and the y-intercept. So I look over here. Here's not y term, not y term, y term. So now I need to get same side. So I need to subtract 6x from both sides. So subtract 6x to get same side. So subtract 6x, subtract 6x. I get 2 y's. No more not y's over here on the left. Left side's just y terms. 2y equals 8 minus 6x. Now what do? I solve. I divide by 2 on the left, divide everything on the right by 2. Divide by 2, divide by 2. I then get y is equal to 8 divided by 2 is 4. And negative 6x's divided by 2 is going to give me minus 3x's. Now I can read off what the y-intercept and the slope are. The y-intercept is a number all by itself. So where does this story start? It starts at 4. So I get y is 4. Right there, number all by itself, right? As you recall, the book's going to write it as slope first, but I think it's easier if we write y-intercept first. So instead of writing this as mx plus b, I'm going to write this early on when we're first learning this as b plus mx. So that number all by itself is going to be 4. That's my y-intercept, because if I put 0 in here for x, it's just y is 4. So y is 4. And then how is the line changing? Well, that's the slope. It's going down 3 for every x. How do I write negative 3 as a fraction? It's negative 3 over 1. So that's my slope right there. My slope is equal to negative 3 over 1. So I go down 3, right 1, down 3, right 1 if I want another point. Got a few points. I can now easily sketch in my line, and it looks like that. All I needed was a y-intercept. In this case, y-intercept, or b, is equal to 4. My slope, and we use the letter m for slope, is equal to negative 3. I have my y-intercept, I have my slope, I can graph my line. Where does my line start? Well, this is my y-axis right here. My y starts at 4. And what's happening? It is going down 3 for every x. Down 3 over 1 for every x. That's how I know how steep it is, what its slope is. That is it for 4.5 day 1. Your homework is day 8 on the assignment sheet. I will be checking that when I get back. So the last part of class, I expect you to be working quietly in your seats the whole time until the bell rings. Okay, thank you very much, and have a great rest of your day.